Save. Updates. There we go. All right. I think I should be good. Where's my audio? How is everybody doing? Today is Tuesday. It's Tech Tuesday. It is IAEI News Live Tuesday. And we are back. Last Tuesday was a pretty busy day. If you recall, we had two sessions. We had an evening session with Mr. Tim McClochie, and we chatted about. We did what did we call it? We called it the shocking truth, when we went through just misconceptions, or we either disproved statements or we proved them. One of the two. Laurel. Excellent. Thank you. I didn't have my audio up, and it's kind of loud, so I think I'm going to lower it just a hair. Anyway, I appreciate everybody dialing in. So today, I'll tell you what I decided, David Englehart. I'll tell you what I decided, and I got to find my buttons. Where's it at? There it is. David Englehart in the house. And we've got Laurel from Omaha. So I'll tell you what I did, David and Laurel. I took a really quick look at comments and on the channel, on some of the videos, and there were comments, there were questions in there, there were statements, there was some good dialogue, and I did not realize how much material is out there. So I thought, why not take a session and take a look at some of the questions and comments that have come in. So that is what I'm doing today. And I'll tell you, as I started looking down through some of the comments, hey, Nihad, Tommy D, Nihad in the house. Nihad, as I looked at some of the comments that came in, there are a lot of really interesting comments. I put one of the comments into a Word document, and it's 1,550 words and 4 pages. And there's a lot of really good information in there. So what I thought was, and what I thought was really interesting, and this was one of the drivers. Morning from Utah, yummy fudge. I'll tell you what, one of the drivers for today's session was this statement right here. It said, "Please don't delete my comment. I promise I'll try to back it up because a shared understanding of all things electric is so important." And I thought I would never delete a comment unless it's solicitation and a lot of different little reasons. But there's a lot of really good stuff out there. So what I thought I'd do today is take a look at some of the comments that have come in. I started throwing them in a PowerPoint slide deck, but I quickly realized there are some comments that are just too long, and I really think we should walk through them as a group, because I think they're important. So, but I am going to take a look at some of these items that came in as a comment, and what I have to do is I've got to figure out where the button is. Where is the button? I have me and iPad. That's not what I want. Intro. I don't know what this. Oh man, I've got to figure out the screens. Hey Jensen, what's up? It's Jensen. It's Jensen Berg from good old West by God, Virginia. Love the fact that you're here, buddy. My fellow West Virginian. Love to see you here, buddy. Okay, so here's what I'm going to do. I'm going to try something here because I can't find the right button. I think it's this one. Yeah, well, this will do. All right, I don't have the IAEI logo down there, but you know what? I can add it. Let's go back. Me. Oh, me and monitor. No, me. Oh, I know what I'll do. Here's what I'll do. Watch this. I go like this, and I do tertiary, and there it is. There we go. All right. How do I now get rid of that? All right, there we go. So this comment came in as a comment to the video from last week. And it was, let me do this. There we go. It's probably a little bit better. It was a comment. Remember the video that we did last week was with Tim McClochie talking about those gray areas and dispelling the myths. And this individual says, we desperately need to simplify the NEC. It would improve the installation quality of every electrician around the country, and these myths would not exist. I cannot disagree with what this gentleman is saying. What do we got here? David says, we desperately need it would improve. Yes, that's it, David. 6 days ago, that came in. And honestly, I think he's onto something, because I like his first statement. It says, it would improve the installation quality. So think about that. Simplifying the NEC will improve the installation quality. Yummy Fudge says, one of the best statements that could be made. Things like positive language on requirements and less exceptions. I don't disagree with you. In fact, I was just writing a blog post. Yummy Fudge, and I made the statement in that there are exceptions to the rule, but we have to be very careful when we decide to implement those exceptions. So when you have a positive rule and you say, well, I'm not going to do that because I'm going to do something a little different. Anytime you want to take a different approach than what's straightforward, you've got to make sure you cross your T's and dot your I's. And that adds complexity. And series ratings is a great example. Series ratings. In Article 240, if you are not going to have two overcurrent protective devices that have an interrupting rating to stop the flow of whatever current that you calculate at that point, and you decide to put something less than the interrupting rating, less than the available fault current as an interrupting rating, and marry that with something that has an appropriate interrupting rating, and they both are going to work together, you've got to make sure you cross your T's and dot your I's. There are additional rules. There's marking requirements. There's motor contribution rules that you need to think about from a design perspective. So it's very important. Clarity, and so there is something to be said about clarity through simplicity, and then how that translates into what this individual was saying. Plus, it's two different groups writing about one topic. Yeah. No, you're not right. You're not Yeah, and I think what you're saying there is especially when you get to, and I know that because that's going to be a topic, I want to bring up some comments that were made about services. Anyway, that was one. Where to find the maintenance of capacitors and power factor correction system. I think we talked about this, but I can't remember where. You know, my challenge is I'm getting to an age, I don't know if it's my age, I don't know what it is, but sometimes I will have a conversation with somebody and think that I did it on a live stream. Or I'll do a live stream and think, well, maybe that was a conversation. So in any case, what this one ended up, I went down the road of trying to find maintenance of capacitors and why this individual was asking this question. And it was related to a 70B program that we did here on IAEI News Live. And the problem was that in this last cycle of 70B, we made it a standard. And if you recall, in the discussion of 70B, when we went to a standard, we had to take some of the language that was in 70B and we had to modify that because it's no longer a, I got to mute this, which means I'm not going to hear the comments coming in. But, and I'm going to mute this over here. So, the problem was there were I don't want to say requirements in 70B. There was language in 70B that dealt with capacitors and power factor correction that never made it into the standard as it's written today for 70B. So what this individual was probably used the document. I don't know if that's for a fact, but I know this individual, I would guess this individual probably used the document for a specific purpose, meaning capacitors and power factor correction, and all of a sudden it was gone. Or this person was truly saying, what do I do for maintenance of capacitors and power factor correction systems, and went to 70B and didn't find anything. So one or to other. Now, what 70B does do for us is it tells us, and I'm going to just pull up my edition, latest edition, in my NFPA link. You know what I'm talking about. In NFPA 70B, in the general requirements, they'll tell you that electrical equipment shall be maintained. I should be able to. I can do this. Watch this. Can be maintained. Electrical equipment shall be maintained in accordance with manufacturer's instructions and applicable codes and standards. So what that's basically telling you, I'll make sure I hit the right buttons here. What that's telling you is that at least my guidance to who asked that question would be, go to the manufacturer of those capacitors and power factor correction systems and find out what they recommend from a maintenance perspective. Otherwise, what you basically are going to have to do, if you're looking for requirements, make a public input to 70B. If I look at, see, I'm not on the committee anymore. I handed those reins over to a gentleman within my organization. But if you go to nfpa.org/70B, I know they're mid-cycle, coming to the end of a cycle, if I'm not mistaken. If you go to the next edition, you can view the public comments online. So you can see the public inputs and the public comments. And let's take a look and see if the latest edition has a new chapter for what we're talking about here in power factor correction and capacitors. I'm not seeing anything regarding capacitors. And even if I go to switchgear, circuit breakers, panel boards and switchboards, substations and switchgear, which if I go back to look at the previous, that was Friday. Yeah, that was Friday. So that was a different channel. But so in 70B, if I look at chapter 12 for substations and switchgear, I'm going to do a control F, and I'm going to look for capacitors. Yeah, there's nothing in there. So honestly, there's no content even in what I can find in the latest edition. So we really need a chapter on capacitors and power factor correction systems. So if there's anybody out there who's watching this, who manufactures those or works on those, who designs those systems and gets into this discussion of maintenance, preventative maintenance on capacitors and power factor correction systems, reach out. We can help you generate some public inputs for the next edition of 70B, which will be in 3 years. But public inputs are going to be coming in soon. So that's what I would say about that. There was another one, where to find the requirement to follow maintenance according to equipment manual. I would go to 70B. I would go to 70B. I would go up here to NFPA link. So the first thing you need to do is get your NFPA link. What do they call that? What do they call that? Membership? Not a membership. It's an NFPA link. Is it a membership? No, it's not a membership. Whatever it is. Sign up for NFPA link. Pay the monthly rate. Whatever that is. And if you're looking for the manufacturers, I would go to the general requirements in Chapter 4. And 4.1 says right here in the beginning, electrical equipment shall be maintained in accordance with the manufacturer's instructions and applicable codes and standards. And it says this standard is not intended to duplicate or supersede manufacturer's instructions. The committee wanted to make it known that you should follow your manufacturer's instructions. And I would relate a good, in my opinion, a good example of this. When you have like my car, okay, my vehicle, we changed the oil in it every 3,000 miles. I was astounded when I looked at the user's manual that it recommended like every 5,000 miles or something stupid like that. I don't want to say stupid, something like that. And I would never go 5,000 miles. I wouldn't want to go intentionally 5,000 miles to change my oil. But if you're following manufacturer's instructions, may be less stringent than what you see in these documents. And they may have that on purpose. They may say, look, that my vehicle manufacturer may say, hey, we have done certain things. We put filters in for the oil. Whatever it is they did. And they've determined you don't need to change the oil every 3,000 miles. You can change it every 5 or 10,000 miles. Well, then that's what they did. And they're making that call for a reason. So you can follow that, or you can elect to do something more stringent. Okay? And what they did with 70B was give you that opportunity. All right? Yummy fudge. Yummy, 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 yummy. Yay, a statement in the NEC may be correct, but not well understood, and it seems at times, at least in the response I see, it feels like some public comments don't always get the attention they need. You know what? Yummy fudge, I don't disagree with you. In fact, there were a few public comments on, it was panel 2. Was it panel 2? Yes, it was panel 2. And I'll tell you where it was. I'll tell you exactly where the public input was. And we rejected it. It was in 210. It was I know it had to be 210 because we don't have 215. But it was in the ampacity discussion. It was minimum ampacity rating, conductor's minimum ampacity. Okay, here's exactly where it was. The task group came out to reject it. And I'll tell you what, and I'm gonna move it. I'm moving things around. I'm getting crazy over here. Getting crazy. Okay. Here's what we got. So, it was in this area, minimum ampacity, and in this section right here, when it says, where a branch circuit supplies continuous loads or any combination of continuous and non-continuous loads, the minimum branch circuit conductor size shall have an ampacity not less than the non-continuous load plus 125%. The submitter's point was, when you use the word ampacity, you are bringing in the conditions of use. And this first one ignores the conditions of use. So what the submitter said was, he wanted to, or she, I can't remember, the submitter wanted to add language after ampacity, and I'm going to paraphrase, something like, should have an ampacity that does not include the conditions of use, not less than the non-continuous load plus 125%. And that statement is 100% accurate. It's 200% accurate. So, but we rejected it. And the panel rejected it. And I made the statement at the panel, how are you going to tell this individual that they're wrong? Help me understand, how are we going to agree that we're going to say that individual is incorrect? That individual was 100% correct. And, in my opinion, would have added clarity. But we said doesn't add clarity, or whatever that key phrase is that we use. So, in any case, sorry about the squirrel, but it is so true that we need to make sure that when we make our public inputs, that's the least we can do, is make a public input. The most you can do is be at the panel and ask to speak. A mid-road, say, for example, they put in more requirements around capacitors. They could present to the task group that's appointed to review that public input or comment. Those are all things that can happen short of actually being at the meeting, either in not Hilton Head anymore, on the East Coast or the West Coast. All right, so at least we know where to find this one. Beginner EE here. Do you have to bond the grounding system for telecom equipment to the electrical service ground rod in a building? And what I loved about this one was a person asked the question and another person answered it. That is phenomenal, because what that tells me is people are reading the notes and helping each other out. That's what this forum is all about. It's not about this guy. It's not about this guy doing this way. It is about creating a platform so that we can communicate together. The chats and all of these different chats are very critical and important. Go out and look at the comments that come in on the IAEI's YouTube channel and be a part of the discussion. The discussion doesn't have to stop when we get off of this program on Tuesday. In fact, you can put more words in your comments. I love the words, I love the comments, and I love the questions. And that's why I wanted to make this session about that, to promote more of that. I was honestly astounded and very well pleased to see the dialogue that we have on our YouTube channel. It's phenomenal. That's what it's all about. It's not about me. It's about a forum for all of you to communicate. So yes, I will do a squirrel every now and then when I'm thrown the bone, but the comments and chats are very well worth it. So hopefully that's what you guys and gals show up for. Is there a trigonometric, I said it right, trigonometric. It's trigonometric number in complex analysis. This was on the discussion of, and I don't even know if I can do this. This was on the discussion that we had related to complex variables. Now, if you recall, remember what complex variables is. Ooh, I wonder if I can do that. Complex variables, we use them all the time, and we just don't realize it. When we talk real and reactive components, we're talking trigonometry, okay? And I don't know. And one of the most famous aspects of trigonometry and what we do is, I don't even know if I'm doing this right, is, yes, the power triangle. Okay, so it is doing it right. So remember, when we have a triangle, delete this again, hold on. Where's my delete button hole? So we have the, this is how I know it. We have a right angle and we have a hypotenuse. So we have, this could be vars. This could be watts. This might be resistance. And this could be impedance, right? And then this could be VA, or it could be Z, right? So we have R plus JX equals Z at an angle. We use trigonometry every day of the week, twice on Sunday, when we are in our trade. My earliest introduction to it was working with my uncle on a job site. We were we were putting a structure up, and he needed to make sure it was square. So he gave me a rule. He gave me the dumb end of the ruler, and he said, "I'll tell you when to stop." And he measured 3 foot. Then we measured 4 foot. And then he had to make sure that the other was 5 foot. And it was a 3, 4, 5 triangle. It's trigonometry. And I asked him what we were doing, and he sat down and he grabbed a piece of paper and he drew the triangle and he showed me and he helped me understand trig. And I was, oh my gosh, I was in grade school, maybe 5th grade or something like that. And he was showing me the math, and I knew it. I knew how to square things up. And then later on, as you go through life and you get into our trade, you talk about real and reactive components, watts and vars, power factor correction. So is there trigonometric numbers in complex analysis? There are, and I'm going to say that it's probably not as complex as you think. At least that's my story, and I'm sticking to it. I loved this dialogue. I don't know what it is I said. In fact, I started to watch the video. There was a video I did, I believe it was on Article 409, for industrial control panels. And this gentleman says, I work on German, Swedish, and Italian-made machines all the time. What you just said is a bunch of garbage. I love it. Some Italian manufacturers do make subpar equipment sometimes, but not German or Swedish. And then the dialogue that ensued after that is beautiful. It's funny. I think it's funny. It's probably emotional for some people, but I just thought it was interesting because there was a little banter back and forth. I don't know what it was. I went through and watched 3/4 of it, of the video, and listened to 3/4 of it, and I can't find anything where I think I said anything that international equipment, I would call it, is inferior in any way. I probably said something about listing requirements. I couldn't find it, but I probably said something about listing requirements, and then the fact that the NEC is the National Electrical Code expects products and solutions that are listed to standards that are developed in combination with the National Electrical Code. So if I come back over to here in NFPA link, and it's not there, it's in, I think, examination. Yeah. Substitute term by application. It is the intent of the code that factory installed internal wiring or the construction of equipment need not be inspected at the time of installation of the equipment, except to detect alterations or damage if the equipment has been listed by a qualified electrical testing laboratory that is recognized as having the facilities described in a preceding paragraph, and that requires suitability for installation in accordance with this code. That requires suitability for installation in accordance with this code. So what that does is, if you have a piece of equipment that is not listed to UL standards, it could be an IEC standard, it could be an international standard. What that does is, this language basically tells the inspector, you need to look at this to make sure that that product meets the requirements of the codes and of this code. Requires the suitability for installation in accordance with this code. So what would I think of? Bending radiuses, working space, ampacity of conductors. There may be cases when you look in a listed assembly where a smaller conductor might be used for whatever reason, but it's a part of that listed assembly. It's tested as that listed assembly. It may not be a smaller conductor. It may be a conductor with an insulation type that you would go, that would never be able to be permitted to be used in the field. Well, that might be true per the code, but per the standard, because of how it's tested and listed, you're permitted to use it in that application for that specific purpose. As long as, again, that's why the inspecting agencies are looking to make sure that it hasn't been modified. But if you have a product that comes into our markets that, say, is from Germany or Sweden, and these great organizations and companies that have a mind for detail, if that product is not designed in accordance with the code, the installation requirements that it's going to have to be applied against, you still could have a problem. Not that it's a bad quality product, it just was not designed in light of these installation requirements. So when I read this one, I don't know what it was that triggered this individual. I love what you just said is just a bunch of garbage. I love that. And then you know what that reminded me of? It reminded me of I did a 70E presentation in, I'm not even going to go down that road. Next time you see me, ask me about what was said to me after a 70E presentation in Texas. I would love to share that story with you because it was funny. All right. We got some notes. I'm not listening. Okay. Sorry for throwing a squirrel. No worries, brother. The problem and solution is only 300 plus years old. That's Pythagorean theorem, and Robert pointed it out. That's exactly right. So that's the thing. It's funny how per unit. It's another engineering tool that's in the electrical engineer's basket. I learned per unit in college, and I always thought it was an electrical engineering thing. And I was helping somebody with their PE license, studying, and I was going over per unit. And he was a mechanical engineer taking a power systems engineering PE license. And I mentioned per unit, and I was explaining per unit like I felt like I was explaining per unit to an individual for the first time they've ever heard of it. And they were like, "Oh, we use this in mechanical engineering." And I'm like, "Oh, really?" And I'm like, "Oh, yeah." And then I talked to a few other trade people, and they were like, "Well, yeah, it's not called the same thing, but it's a percentage. Basically, you're working on percentage. It's per unit." So anyway, we all use these things in our trades, and sometimes we think we're the only ones that use it. For a specific example, in emergency disconnect push button style, Siemens wanted $150 for one, or I can get one with the international standard for less than $40. Meets all the similar requirements. So that's the thing, Yummy Fudge. So a couple advantages when you look at some of the products and solutions that are made to the IEC standards. Here's what I've learned. Here's what I've learned. And again, this is my opinion, my perspective. What I've learned. I've had some people tell me this, and when they told me this, I started thinking about it, and I realized they might have a point. I had an individual tell me one time, he said, "Tom," he says, "here's the difference between an IEC piece of equipment and a NEMA piece of equipment, and specifically looking at motor controllers." His comment was, when I need a NEMA motor controller, boom, 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 I'm done. If I need an IEC motor controller, I have to engineer every application. The controllers are much smaller. They're built for specific applications, so you really have to be educated and know exactly what you're going for. So they put a lot more weight on the engineering behind the application of the product. I don't know if this is 100% accurate, but I use this as one of my it's one of those things, the seeds that plant in the back of your head, and then as I look through requirements, I think, is it right or is it wrong? So his comment was, whenever he engineers something to an IEC with using IEC products, he has to take a lot of care and time to make sure he picks the exact right one, and it takes a lot of engineering work. In the NEMA market, it's boom, 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 you're done. Now, you may bring a tank to a knife fight, but you're not going to have a problem of picking the wrong product for the application. It's not as complicated. It's simpler. Is the product larger than maybe what it needs to be? Quite possibly. So that was his perspective of it. Some switches and whatnot may be less expensive, maybe smaller. I've seen it more from a size perspective as opposed to a price perspective, but that's just because I don't get involved with pricing. That's not in my job role. I'm an application. Don't ask me how much something costs unless I bought it for the house. So anymore. And any prices that I even come up with are going to be so old you'd laugh. So anyway, I was able to find a Siemens for much less and used it, but in my opinion, either was fully up to the task just without the UL logo. You know what? I can't speak yay or nay on the quality of what's inside or how it would perform over time. I can't speak to it. Might a manufacturer make a product, put it through a certain series of tests and get a label on it and ship it? Take that exact same product, maybe they put it through the exact same tests and they don't put a label on it and ship it. Maybe. I don't know. Don't know the answer to that question. Can't speak for any manufacturers out there. Time will tell. That's all I can say. It seems IEC is an acronym for International Electrical Code. No, it's the International Electromechanical IEC. I'll tell you what it stands for. International Electrotechnical Commission. So it's an International Electrotechnical Commission, the IEC. I'm a part of that. I'm part of the USNC. We make a lot of product standards. Declarations, they usually now you can get a third party to certify your product against an IEC standard, but many of those products are self-certified by the manufacturer. Declaration of that is available upon request. But my point on this discussion is not that the IEC standard may be better or worse than a UL standard. My point is, in this discussion, that an IEC standard is not written to accommodate the National Electrical Code. We have rules in our codes. GFCI, great example. Here in the United States, as part of NFPA 70 and the NEMA world, GFCI is 4 to 6 milliamps. European IEC directives, IEC codes and standards, it's 30 milliamps. One has the concept of let-go thresholds, the other one does not. That's a difference. You're not going to see the term GFCI. You might see a different term, RCDs, things like that. Terminology is different. Designs are different, and if you're trying to apply that product in the world of NFPA 70 and it was not, and the standard for the product wasn't developed and designed with NFPA 70 in mind, that's a challenge. So the language that we see in the code in Article 90 and in 110 reflects the fact that, look, we're looking for product standards, and IEC could have product standards that are designed and developed. It's not that they can't. There are a lot of trinational and global standards that have been put together where you have a set of standards and you have exceptions or specific requirements by country. And you can have third-party view of the product. So I'm not speaking negatively about IEC or international products. It's just that they're designed. That'd be like buying a car that was designed for England and bringing it over here and selling it in the United States. You would look over and say, why is the steering wheel on the wrong side of the car? Well, this was designed for England. It was designed to their requirements. It's not something that we would see here in the U.S. It would be a challenge for us to be sitting on the wrong side of the car. Now, if I was in England, I would say it's the right side of the car. But you get my point. Anyway. Yummy fudge. And not just the IEC, CE is EU safety, and I see it a lot. Yeah, we see a lot of those products coming into our markets, but the language in the National Electrical Code, the inspector has to bless it. The AHJ has to say yay or nay on that installation, and they're going to have to do a review of the solution to make sure that it meets the standards and installation requirements. Is your price ever on the house? Is my price ever on the house? It's always on the house. CE is a self-testing mark. It's a self-declaration, yes. Thank you, David. International Electrotechnical Commission. One of the reps from a nerdle said, CE, oh, Don Gannier, no, bad stuff, buddy. In our markets, probably. Joe Ballard, RCD, thank you. Residual current device. They don't call them GFCIs, they call them residual current devices, RCDs. Thank you, Joe. That comment was in reference to requirements for the use of listed products. Amen, brother. Okay, so let's get back to the point at hand. So I love that dialogue. If you go out, take a look at some of the dialogue back and forth. It was good. I loved it. Now this one here says 4010, the NOx sort of antioxidant compound might still be a good idea just in case of water ingress. The key thing is to make sure that you follow manufacturer's instructions before you apply anything to that product. If they put something in their literature that says do not apply that, then obviously we can't. But in any case, follow manufacturer's instructions. I agree. Oh, I agree. And use U.S. standards. But I still like the original comment that started this whole thing. Me too. Me too, Yummy. I tell you what, when I looked at that, I was laughing because if you look at the dialogue, and I'm not going to pull it up, but I will pull it up. In the dialogue, it said. I had one guy say, what a terrible transmission. And I'm not sure what he meant by that. So this one here said that the response, so one individual said, I worked on a couple of great made in Italy 500-ton plastic injection machines. We had a so-called engineer that back in the 80s purchased a $69,000 box erection machine rather than a bulletproof made in USA. Tell me that guy's not biased. One that cost $90,000. He told us that it had a computer for troubleshooting. Yep, 6 idiot lights. Machine was down at least 4 months a year because when they flew in a mechanic from Italy, he said it also had electrical problems. So weeks later, an electrician from Italy would fly in and get it working. And it goes on. I'll tell you what, it's just, I mean, it's for that person who had purchased the product and had problems, probably wasn't a good story. But that comment from my German friend was interesting. All right. Okay. This one was, remember Ryan and I were at the NFPA annual meeting and we did a Q&A session, I think it was, where we did it. I don't know if we were sitting down or whatever it was. The complexity in residential is outrunning typical skill sets of electricians that only do residential. And I believe the discussion that we were having was regarding the amount of technology. Like if I go back in my lifetime to when I graduated college, I graduated from the University of Gannon University with a power systems engineering degree. It was a Bachelor of Electrical Engineering, and it was 1990. We didn't have energy storage system. We didn't have batteries in residential dwelling units back then. I didn't even fathom that. In fact, I don't think, when was the cell phone? When were, I remember seeing cell phones on TV, but when did the cell phone hit the streets? Let's do a search. It was mid 80s. So it wasn't until the mid 80s that they became widely available. So I graduated in 1990 from college, and a cell phone wasn't in my future at that point. It wasn't until I started at Eaton that we had one cell phone that we all shared, because we were on call. But in a residential, it's outrunning the... So we have batteries now. We have photovoltaics. We have a lot of technology. We've got these systems. I can say the word and have this young lady who lives in this little round cube or a little round disc, and she'll turn off lights and turn on lights and make things happen. That did not exist back in the day. So we are doing a lot more in residential homes. Now, you may have been in commercial buildings. We saw batteries for years. I mean, Crystal River Unit 3, we had a whole battery system for the power plant, for the emergency system. I was in Schrevers Air Force Base. I mean, the battery rooms in Schrevers Air Force Base was unbelievable. There's so many different uses of that industrial. And we had communication systems. We could tell you how much energy was being used on different branch circuits. I can tell you that now from my phone. I can remember the first day we had a compact iPac. It was a handheld unit. And we had Iconics software or Wonderware, I can't remember, on it. And I could walk around as long as I was connected to the internet, and I could see our power distribution systems for plants, even some of our customers, on that compact iPac device. I never would have thought I would have that in a residential dwelling unit. Those of us staying sharp on code or are not mindful that the typical resi guy has never actually calculated fault current. That's true. Incident energy, true. And PV energy storage and the generator craze. Transfer switches are new to a lot of them, even surge protection. That's true too. Some are still resistant to AFCI and GFCI. Oh my gosh. And even advise the homeowner to remove after inspection. God, I wish that was not true. Load management systems and EVs are challenging them as well. The new sections of the NEC that include dwellings that are easily understood by code people and those experienced in commercial industrial, I get it now, are really challenging, and even the concepts are unfamiliar because they have never dealt with it before. The IAEI should press for special education programs for topics that are new specifically for dwellings and recognize the people in this sector need education from the most basic concepts and up. Absolutely right. We got to get back to the fundamentals and then build up from that, because the residential contractor, the residential wireman, inspector, designer is seeing technology that they have not seen before. And what might be fundamental for a commercial and an industrial person is not for this residential, yet the residential individuals are moving into that space. All right. 15K, this was a good one. Remember I did a 15 kVA transformer example. And I don't know what it is I said. I'd have to go back and look at it. But this gentleman commented and said, 15 kVA transformer, 2-wire, 480 volt, primary protected at 40 amps. So if we go back to our math, if we go back to where we once belonged, get back, Jojo. If we do this, how do I do this? iPad. So we're going to do some math. We have a 15 kVA transformer. I'm going to assume it's, it's two wire, not 3-wire. So it's a single phase transformer, 15 kVA transformer, two wire, 480 volt primary protected at 40 amps. So if I want to know the primary full load amps, I take 15 kVA, 15. I don't have to divide by 3 or anything because it's a single phase transformer. Divide that by 0.48 kV. 31.25, and they say they're protecting it at 40 amps at 1.25 times that. You can, 40 amps. You see where he's getting his numbers from. So you're saying I can feed a panel 240 volt single phase 200 amp panel. So if I have a 15 kVA transformer, 15, and the secondary is 240, 0.24 divide, that's 62.5. Multiply that by 1.25. That's 78 amps. Go to the next higher, 80 amps, something like that. I don't know what the next higher is. What's Article 240? We go to Article 240, Chapter 2. I'll never find Article 240. I don't know about you guys, but I'll never find Article 240 in NFPA 70B. I don't know how hard I can look, but it's going to be tough. It's going to be real tough. If I go to Article 240 and 240.4, I think it is, 6, 240.6, is it 6? 240.6, yep, 240.6, 78 amps. Next higher is 80. So I go to 80 amps. And it says, so you were saying I can feed a panel 200 amp main as long as the secondary conductors are rated 200 amps, even though the secondary output capabilities are much less. As long as you are protecting that 200 amp panel by the maximum size overcurrent protective device for the secondary. Oh, hold on. No. For Article 450, we go to Article 450. Oh man, I almost answered that one too fast. This is a single phase transformer. So we go to the table. So primary only protection. Primary only protection shall be permitted. So for primary only protection, at 125%, which is that 40 amp breaker. That's primary only protection. I satisfied that. My secondary does not require protection for the transformer. I can put a 200 amp panel board on the secondary. There's nothing that says I can't. If I load it to 200 amps, will I probably open the primary fuse? Yep. But primary only, what's Don Ganir say? Don says, primary only protection is only permitted for 2-wire to 2-wire. So not permitted with Don, good catch. So you would need secondary protection. So you could still put a 200 amp panel board on there. You just have to put secondary protection not exceeding 125%, 9 amps or more. Where secondary primary only primary. So maximum rating or setting of overcurrent protection for transformer 1,000 volts and less as a percentage. Don Ganir, primary protection only, where 125% does not exceed the next higher rating. I was going to say, Don, I don't see anything in the transformers. There's nothing in the transformer in 450.3b that says single phase only. So as long as I'm protecting the transformer, if my primary only protection is 125%, I can go to the next higher. then I'm protecting the transformer. I don't need secondary protection. Now, when I put this panel board on the secondary, if I put a 200 amp panel board on the secondary with a 200 amp main and 200 amps worth of conductor on the secondary of that transformer, because I have to protect that secondary conductor, I have to protect that conductor. I need 200 amps worth of conductor. I can do that. It would be a waste of money. There would not be anything in the code that says that you can't, that I can find. 240.21c. 240.21c. 240.21c says, I believe that's going to be the location, that's going to be your transformer secondary conductors, right? Yep, transformer secondary conductors, you have the length, and it'll tell you have to land on an overcurrent protective device. So if I have a transformer secondary conductor that's 10 foot long, the ampacity of the secondary conductors can't be less. So if I have a 200 amp breaker, 200 amps worth of conductor on a 15 kVA transformer with a 40 amp main line side, I can do that. I can do that. It would not necessarily be practical. I probably would open, if I loaded, I would. So let's think about it. What's the turns ratio? Turns ratio is 240 to 480, right? 240 to 480. So if I have 200 amps on the secondary times 240, how do I go back? How do I go back? How do I delete? Boom, boom. Times 240 times, and divide that by 480, 480 divide. 200 amps on the secondary is 100 amps on the primary. I have a 40 amp breaker. I load that panel board up to 200 amps. I'm going to trip the 40 amp primary because it's going to see 100 amps. Now it's going to take it some time, but it's still going to open. It's going to provide protection of the transformer from overload. So I did what I've told so many people not to do. Applied the conductor rule to the transformer. Article 450 transformer and Article 240 protects conductors. Exactly. Yep. And it's an easy, Dawn, it's an easy pitfall to fall into. I mean, we all do it. That's why I had to double check. I'm like, but that's why we're all together. So to answer this individual's question, a 15 kVA transformer says, so what you're saying is I can feed a panel 240 volts, single phase, 200 amp main, as long as the secondary conductors are rated at 200 amps, even though the secondary output capabilities are much less. And the answer to that is absolutely yes, and it would not violate the code. You're not creating an unsafe situation unless you consider tripping that primary breaker an unsafe situation. I know Donnie Cook used to think about this all the time. He used to say, he used to see secondaries of transformers overloaded. And he'd say, why? Why is it permitted in the code to do that? It is, what it shall be. Yummy fudge. Yet another reason why we need the NEC to be more understandable. Yeah. Well, here's the thing, Yummy. You're allowed to do it. Now, the question would be, do you want it to be prohibited? That's the fundamental question. And I didn't get to this one, but I will at a future one. I've got to run to a meeting I am 4 minutes late for. And that's why my watch is dinging, because they're like, where are you? Where are you? So my encouragement to you is, don't stop at Tuesday at 1 o'clock. Go back, take a look at these videos, watch them later, comment on them. I want to keep reviewing these and take a look at some of the comments. The next one I'm going to go through I converted into a Word document. Here's the one I'm going to look at, and I know they're waiting for me. Here's the one I'm going to look at. I found the IAEI a few weeks ago. Thomas seriously did a feeder installation. It was great stuff. I bought it pipes. I'm very bummed that I missed the stream of 2:30. And then this one here goes through a bunch of interesting things about Article 230. It goes into the definition of service. I put it into a Word document, and this individual talks about the defined term service, and I did a session on the defined term service. I went back and did the history, and I never even saw this. I need to go back and read this in light of what I did with regard to that service. And I'm going to go back and we're going to review this at a future date. Yummy Fudge. Nah, I don't fully agree. I want positive language, helping me know what to more and more. I agree with you. I look forward to your public input. All right, guys and gals, I've got to run to a meeting. Thank you for joining in. Thanks for all the chats. Don Gannier, love you, brother. David Englehart, Yummy Fudge. Robert from Omaha. And can't forget about Laurel in Omaha. Joseph Violi. Nihad El Sharif. Thanks, everybody, for joining in and making this session what it is and making the IAEI what it is for me. And I hope it is for you what it is for me. So take care, stay safe, and please stay healthy. We will see you hopefully next week. God willing, and the creek don't rise. Catch you next week.